In this lesson, we're going to try to figure out how to use the distance formula to figure out how far 2 points are from each other. We first start off with the Pythagorean theorem. It says a squared plus b squared equals c squared, and that's basically saying if we have a triangle and we take the two sides, we square it, add it together, we'd get the length of the third side squared. So when we have coordinate points, they're going to be the same as x and y, some two numbers, x and y. Let's use a as our first point, so we're going to label it by saying x sub 1 and y sub 1. And b can be our second point, x sub 2 and y sub 2. If we look at the y's and we subtract it from each other, we'll get the distance of b. If we look at our x's and we subtract these two distances from each other, then we'll get a. Knowing that the difference between x2 and x1 is a, and knowing that the difference between y2 and y1 is b, we can take that and replace these values into our equations. And then here d is going to be our c. When we replace it into the equation, we get this new equation right here. D squared is equal to x2 minus x1, which is the same as a squared, and y2 minus y1, which is the same as b squared. Here, d squared is the same as c squared. And our last problem is we want the distance and not the distance squared. So that means that we need to take both sides and take the square root. That way we'd end up with just d. And so as a result, this is our distance formula. So in the next example, we're going to look at how we can use the distance formula to help us figure out the distances between 2 points. Alright, here's our first example. Find the distance between 3, 2, and 6, 6. So we need to remember that our coordinates are always in the form of x, comma, y. If this is our first point and this is our second point, they each have an x and y in their coordinate. But we're going to use what's called a subscript so we can tell the difference between these 2 points. So the first point we're going to call x1 and y1, that's a comma in between them. And the second point we're going to call x2 and y2. After labeling these, we can note that x1 is equal to 3. I got that from right here. We have y1 is equal to 2 from the second part of the first coordinate. Then we have x2 is equal to 6 from that second coordinate, and then y2 will also be 6. So now that we have these values, we can substitute them because x1 is equal to 3 and y1 is equal to 2 and x2 is equal to 6 and y2 is equal to 6. That means that they're equal and we can swap them out and it wouldn't change the meaning of our equation. So as you can see here, these values are then substituted in for x2, x1, y2, y1 into our formula. Using our orders of operations, we first have to take care of that inside value first, and as a result we get 3 on the inside and 4 on the inside. Then the next step is to take the exponents, and then we get 3 squared is 9, 4 squared is 16, and lastly we get to add. 9 plus 16 is 25. So now we know d is equal to root 25, but when we take the square root of a number, that's like saying we have the square root of 5 times 5. Since there's a pair of them, one comes out and the other one disappears, and as a result we'll get d equals 5. The next example will work the same way.